want to look, see, I have the best seat in the house by far because I get to look out at the water and the bridges and pretend like I'm not in here talking to you people. Man, it's fantastic. Eventually, I'm just going to be,
So if you stop this, you can remind you where you are.
Yes, yes. Brent, get back to work. All right, so we're a little early, but I'm going to go ahead and get started because this place is full anyway. Today I'm going to be talking about 6 scary surprises. I do a lot of performance tuning consulting. I parachute into the nastiest SQL servers you've ever seen, and I have people pointing fingers at each other trying to figure out what the problem is, and often it's not anybody who's involved. There's these other weirdo things that are at play here. My name's Brent Ozar. I'm a Microsoft Certified Master, which just means I make a lot of very expensive mistakes along the way. And then when I see other people's mistakes, I can go, oh yeah, I broke that too once, and I can tell you exactly how to fix that, hopefully without making as many mistakes as I did when I got started. I'm an MVP, which just means I like to talk a lot. I co-authored 2008 Internals and Troubleshooting, and I co-founded Brent Ozar Unlimited with a couple of my dear friends who are actually here today at PASS and at SQL in the City. So today we're going to be talking about things that are scary and are surprises. Some things you just look at them and they're up to no good. It's very clear when you look at these things, I don't want to go anywhere near them. Sometimes it's a little confusing. You go, what? It's not really that scary, right? How bad can it be? SQL Server is one of those things. When you first look at it, everything looks like it's fine. I love SQL Server Management Studio because it doesn't have any of those big, ugly square blocks that Metro has or whatever Windows UI they're calling it today. At least it's always looked nice and friendly, but you have no idea if the server's on fire. SQL Server knows when things are on fire, but all it ever does is just this little stupid play signal when everything's going to hell in a handbasket. We approach it and we think everything's okay, but in actuality, nobody ever dies, but we spend long weekends slaving over things that we never should have had to look at it to begin with. So I'm going to cover 6 things today that are broken or can really burn the bejesus out of your servers. The first one that I'm going to talk about, the changes coming from inside the house. It's based on that old horror story line, you know, the call is coming from inside the house. So often when we're looking at, you know, the happy database movies, everything's fine. People work together and nobody has permissions on production. And they, you know, we talked about, yeah, you're all laughing already. That didn't take long, even before we got further down. And I'm certainly not saying that Redgate is one of the third-party vendors that would only deploy good changes. But we have those other vendors, right? Surely not them, but other, hey, hi, Hugo, you can come in. It's okay. I dropped the restraining order. You're good. He gave me the best crackers. You call those cookies? Those waffles?
Stove waffles.
Stove waffles. Oh my God, they're good. I was eating those. Yes. Now I owe him all kinds of favors because I've had his precious Netherlands waffles. So we have these weirdo third-party apps that make all kinds of changes, and sometimes we're the people who are making all kinds of changes as well. When I look at a SQL Server, it seems like everything's going fine, even when I drill further down into there. If I drill inside Object Explorer, often tables look okay and indexes look okay. In this case, I've got a customers table. I've got DBO customers, and I've got 2 indexes here, one on customer name and one on date added. And because I was almost going to say I'm a good DBA. I don't suck as bad as I used to suck. I'm decent as a DBA. I actually do have these on the right field. So IX customer name is on the customer name field. I learned the hard way. So now I have a query on here, select customer name from customers, where the customer name equals Brent Ozar. But when I look at the execution plan, it's just doing a clustered index scan. It's not using the index, hey, Annabelle, it's not using the index that it should use for that table. And I would have to know what's going on in order to find out why that's broken. Well, it turns out there are things that can happen behind the scenes with indexes. This is way too small. You can't really zoom in on it. So I'm going to show you a little deeper here. Select blah, blah, blah from sysindexes. What is disabled? Your indexes can be disabled, and you wouldn't have any visual indication inside SQL Server Management Studio. Even inside when we're normally trolling through sysindexes, we would have to go all the way down to the end, but I only just picked out the is disabled field to show you something. Disabled does not mean that they get a special parking spot. Disable means something a little bit different than that. And you're probably wondering why someone would ever disable an index. As it turns out, when we want to load a whole lot of data very quickly, sometimes people will drop an index, but the better thing to do is just disable that index. If you disable the index, the schema is all set up still there. Come on down, come on down. The schema is all set up there, so all you have to do is enable it afterwards, and we're off and running. You don't have to recreate it from scratch. Unfortunately, though, this kind of thing is what usually happens. Someone will disable it, or they'll have an ETL process that disables all the indexes every night, loads the data, and then re-enables it, and someone breaks that nightly process so they don't get enabled again. Or, let's not tell the third-party vendors that we're doing this, but you know how those third-party vendor apps you have that they say you're not allowed to touch anything, you're not allowed to touch the script, and they have all kinds of indexes that are utterly worthless? You can use this trick in your favor. You can disable their indexes, they're still there, and no one will know. And then if it ever gets you in trouble for support, you could just enable it again or say, I don't know, that must have been the last guy. I would never change the schema of your database. It's like a delicate flower. It's wonderful. So there's a few ways that we can get around this little nasty surprise. One is to write a DDL trigger. I'm a huge fan of DDL triggers. I know database administrators aren't usually big on triggers, but these act whenever someone changes the schema of the database, whenever someone writes an alter, create table, or so forth. So how many developers do we have in here? We have a lot. How many database administrators do we have in here? And you all sat right next to each other? You're not like pummeling? It's probably still early. You haven't had your coffee yet. But as you, oh my God, holy cow. Yes, come on in, come on in. She brought a whole backpack full of stuff she's going to throw at me later. So what I often see database administrators doing when they're trying to trap developers, they'll create a DDL trigger so that when anybody does anything in the database, like a create index, alter table, it'll immediately get logged and or emailed to them. That stuff's fantastic. My SP Blitz, which we'll look at a little further down later as well, also checks and alerts you if you've got any disabled indexes anywhere in any of the databases. And then also, one of the things that I like to set up a metric to monitor on is the number of indexes that are disabled, because it should always be 0, unless you're going to do that thing with third-party vendor apps that we talked about and no one would surely ever do. Now, when I say Redgate SQL Monitor metrics, Redgate's SQL Monitor will allow you to create your own metrics and share them with other people. I'm to the point in my life where I don't want any more points or anything on other sites, so will someone please go create this custom metric and you'll get all kinds of credit amongst the user community. People say, that's genius. Where did you come up with that? And you can say, it was all my idea. None of that Microsoft Certified Master stuff. So you can search for terms too, things like unused indexes, disabled indexes, constraints, foreign keys that aren't trusted, and so forth. You can simply click on these off of, did I put the URL back up there? Yes. I'll have this again at the end of the slide, SQLMonitorMetrics.red-gate.com, so that you can download and extend stuff. This is one of the things I like about SQL Monitor a lot, is that you can quickly extend this with the hard work of all your other coworkers out here who constantly get burned by all these bad situations. Another one that I really like, and I wish that everybody would set up, is the number of tables that have no clustered index. This is not one of those surprises, because we usually see this coming from a mile away. But I want to know the instant that someone creates a table that does not have a clustered index, so that I can go back and hunt them down. I'm often the villain in these monster movies, as it turns out. Any questions on the disabled index thing before I go on? Yes?
So when you disable the index, does SQL Server stop tracking usage?
Yes. When we disable the index, does SQL Server stop tracking metrics on that index? Yes. Because obviously inserts, updates, and deletes won't hit that anymore. So, yeah. Yes, in the back.
When standard reports in 2008 show reports alter schema, they'll show the same thing as the schema changes. So instead of the trigger.
So the question was, if you go into SQL Server Management Studio and you right-click on a database, you get these standard reports since like 2005 Service Pack 2. And it tracks a schema change history of people who have disabled things, changed things in the database. It's not always very reliable when we're going through large database migrations and we'll have hundreds of changes fairly quickly, or we go for a long time. And there's no alerting built in either. That's the only drawback. But then you can get some of this information without setting up anything at all, which is nice. More questions before we go on to the next monster? So the next one is an awful, awful cannibal, and I run into this a lot. It's not very well understood. It's actually better understood in the Exchange community than it is in the SQL Server community. I'm going to show you the world's simplest graph for SQL Server. It all boils down to these 4 boxes here. Our end users are going to ask the SQL Server for data. SQL Server runs on the CPU. He's either going to get the data from memory. Don't you hate it when people touch the laptop screen? It's not my screen. So I can't have nice things. Feel sorry for the next presenter. Hold on, let me get my chocolates out. The SQL Server is either going to get the data out of memory or it's going to get it off of the hard drives. And this really boils down to the size of our memory and the size of our data. If we have 64 gigs worth of memory, and we have a 100 gig table, I didn't say database, I said table just to keep things interesting, or to keep things simple. We're going to scan across that 100 gig table from start to finish. If I can't cache it all in memory, the speed of that table scan boils down to how fast I can get the rest off of disk. 100 gigs, if we store as much as we can in memory, 100 minus 64 is 36 gigs worth of data that I'm going to have to get off the drives. The fastest your query can finish is however fast it takes to get 36 gigs worth of data off the drives. It takes a long time to copy 36 gigs of data off of hard drives. In my session at PASS this week, I relate these down to real-world numbers. If you are doing a brisk walk at 5 miles an hour, which is a lot faster or a lot slower than Yanni went on her half marathon yesterday, if you were doing a brisk walk at 5 miles an hour, getting data that's like getting data off of hard drives, whereas getting it out of memory is the speed of light. That's the same differential there between these two. Would you rather be walking or going the speed of light? So it's really important to me that I cache as much as I possibly can. And there's a lot of advice out there why you should maximize your memory by not remote desktoping into the server, by not running SQL Server integration services on the same machine as your server. Don't run SSMS from the server. Remote desktop in somewhere else. This is the most important memory that you have anywhere on your SQL Server. You need to use it to cache data. And of course, get as much memory as you can afford. This used to sound ridiculously crazy expensive, but for those of us who are going to PASS, we're going to blow more than this on Jägermeister this week, let alone any kind of performance tuning stuff. This used to seem crazy expensive, but it's nothing compared to Pat's camera bag. I mean, Pat has more lenses than that in his camera bag. But there's another problem, and we kind of have to dig a little deeper for it. This is Windows Task Manager, and I'm looking at, I like clients like this. I mean, I like all my clients as long as they pay the bills. I don't like the ones that don't pay the bills. But, so I've got 80 cores here and 1 terabyte of RAM. Yes! But it's not always that pretty, right? A lot of us are kind of budget constrained, and we don't have all the much money in the world. So it looks closer to this. We've got a 4-core server with about 64 gigs of RAM in it. And let me zoom in a little bigger so that you can see that there. It's a little bit of a problem here. We are used to monitoring available memory. That looks like we've got a lot available. But what's this free number? As it turns out, with 64-bit versions of Windows, when we remote desktop into the server and we copy files, we drag and drop a backup file, we drag and drop a trace file, send things to each other, download a service pack and copy it from one location to another. Windows will helpfully cache that for you using your memory. That memory is not really available even though it's included in this number. It is available to the OS to do things with, not SQL Server. The memory that's available to SQL Server is this. When you remote desktop into one of your SQL servers that's having performance problems, the first thing you should do is go look in Task Manager and look at the amount of free memory, not the amount of available memory, because available memory really is not. This problem was surfaced more on the Exchange team first, because they really need memory even more than we do. And this wasn't a problem for us back in the 32-bit days. It's a huge problem in 64-bit days. And I've got a little example of that there just so that we can remind ourselves. I've seen it get worse. So this is a cluster. I bet a lot of us in here have clusters, have like an active-passive cluster where one node is sitting passive at all times, waiting around to fail over. And I bet that's the node that we remote desktop into and we run things because we think we're not hurting anything because it's not doing any work. But we're just ramping this number up and up and up. The cache number continuously gets higher and higher. And when you fail SQL Server over to this particular node, sad trombone. All of a sudden, your SQL Server is not going to run well at all because it's only going to have a few megabytes of memory to play with because we never reboot our passive node. It's really funny. For the longest time, Windows sucked so bad that we were like, well, let's reboot our server every week. And then we got smarter and we're like, oh, Windows is great. We shouldn't ever have to reboot our server. Everything that's old is new again, just like a lot of the clothes that I wear that I refuse to throw away because skinny ties came back in style. Yes. Not that I'm really that excited about skinny ties, but now I'm seeing more and more people regularly reboot their servers, especially the passive nodes, to fix this problem, to free up memory. Because, yes, Hugo.
No other way to free up the memory other than rebooting, because it sounds like such a harsh
Yes.
way to handle it.
That's a great question. I'm glad you said that. So there's two ways you can fix this problem. One is to use an undocumented utility from Mark Russinovich, the guy behind sysinternals tools at Microsoft. It's undocumented. It does work. I'm just not wild about running undocumented utilities on my SQL Server because you have to leave it running as a service in order to stop this. The other way you can do this, it's really interesting how this works. I can copy a file that's, say, 50, 60 gigs, and then delete it. And Windows is smart enough to free up the cached memory if the file was deleted. A little odd, right? And of course, the other way that you could fix it is just don't remote desktop into the server and don't copy files. Oh, yes, go ahead.
Does file copying just apply to those remote desktop sessions, or does an SMB session pulling off a backup log have the same effect?
The question was, does it just remote desktop or SMB? So it's anything that's done from that server. It can be a scheduled task, something that runs as a command periodically. As long as it's done on that server and copies a file, it's going to be a problem. There are utilities like Xcopy, for example, has a command line switch that can do an unbuffered file copy. It's slower, but then we don't run into this problem. Ideally, what I do is I just remote desktop into a different server and pull the file off of my SQL Server, and then it's not a problem. Yes?
That file system cache does return to the operating system.
To the operating system, yes. To SQL Server, no. Windows can crunch this out of the way, but if SQL Server looks at its target memory, it's not going to go ahead and say, oh, I've got this additional memory that I'll take advantage of. It stops there.
Well, eventually that gets aged out. That's in a permanent state.
If you're okay with waiting weeks, yeah, you're good. Yeah. Yes.
I guess kind of like him. I thought when the free got reasonably low, under 100 or something like that, then it would trigger the OS to do a low memory flag and start. No?
No.
Well, when does it set the low memory flag on the OS?
Eventually, if there's enough pressure from cache to where Windows is going to start paging out, yes. But not stuff like SQL Server. Yes, Mike.
Do you know how that interacts with things like PowerShell remoting? Do those release that memory nicely or no?
I don't, but here's where you can look for. This is why I keep text editor up. If you search for Windows too much cache, there's an excellent blog post that goes into, and I think I've got it under, if you go to brentozar.com/go/filecache, there is an insanely dry blog post from the Windows team that's about 20 pages long that goes into in-depth, and it may have something about PowerShell remoting in there. The question, don't ask Brent about PowerShell. So I have this religious feeling about PowerShell. it's a lot like, everybody thinks they're a good driver, but everybody else sucks. I don't need PowerShell, but I think all of you should have it. It's wonderful. And I just don't work on lots of servers at once. Usually people call me in to fix one server. They don't bring me in to fix a lot. If I was still a full-time DBA managing a lot of servers, I would be Mr. PowerShell. I would be all over it. So there's my halfway plan. I think you should learn everything, all of it. Don't stop learning any of it. So here's how you're going to fix it. Monitor the free memory amount, not just the available. Most software out there will only monitor the available memory. And that task manager shot that I showed you is actually out of Windows Server 2008. 2003 doesn't even show you the amount of free memory, which really sucks. Sets equals max memory size. There's a couple of different formulas out there on what you should set that as. Mine is probably the simplest. There are more accurate ones that you could use. I just start with 10% free or 4 gigs, whichever is greater. That should leave memory on the table for you. You should not be using this much memory at the OS level. You can always crank that up higher later over time. Just start here, especially if you go in an Internet Explorer from the server, run YouTube and all that stuff, especially because you're watching my videos. Who could blame you? And then finally, don't remote desktop into the SQL. Don't run files. Don't copy files. Don't run SSMS. None of that stuff. Stay out of there. That's not what it's for. I didn't say run Windows Core Edition. That's another problem altogether. Next thing that I'm going to talk about, everybody buys these solid-state drives. Remember the problem that I came up with earlier. We have that very simple graph. Well, if walking really slowly as opposed to running the speed of light, what is it with good solid-state drives? Well, it's all over the place, and it really depends on who you buy them from and how well you set them up. Boy, is it just me or is it hot in here? God, we're on fire. Yes, not exactly. I'll try to be more gentle and quiet. So these are a really typical deal. FusionIO drives are supposed to be blazing fast. You put them into your servers, off you go. OCZ, Intel, all of these are exactly the same thing. And my customers do these because they're a good deal relative to typical SANs, but here's how the life cycle on that goes. People throw it in, turn around 6 months, and all of a sudden everything's back where it was before. And they don't understand exactly what's going on. The best way that I can illustrate this is from Barney in How I Met Your Mother. I did not come up with what I'm about to say, he did. So if it's offensive, it's his fault, not mine. Explain that. So he says, if a woman is this hot, she's allowed to be this crazy. And women, you can say the same thing about guys. Although guys, we're always usually just down on the crazy scale. We're not all that hot. At least me. I've seen myself getting out of the bathroom. It's nothing on the hot scale. It's just the crazy scale. So if a woman is this hot, she's allowed to be this crazy. We put up with solid-state drives because they are way hot, but they are also way crazy. There are a lot of problems with solid-state drives. The first off, FusionIO, their drivers require a very large amount of memory. And you have to set that aside and leave it, not take SQL Server up to huge amounts of memory. This amount of memory that they need is based on the sector size and the drive size. This can be 50, 60, 80 gigs worth of memory that you have to leave free just for the drives. It is detailed beautifully in their manuals. They do a really good job of explaining how you calculate that, but I know how you guys feel about manuals. You learned that from books online, right? You go, oh, God, no, I'm just going to put the CD in and go with it. And then I'll call the consultant later, which is why I love all of you people. Yes, you're great, because I read the manual. So most solid-state drives, it's not true. I don't read the manual either. I just do after you call me, and then I read the manual. Most solid-state drives slow up as they fill up, slow down as they fill up. What do? We throw temp DB on there, lots of files, grow it out to the size it's supposed to be, and it went blazing fast when we first tested it with SQLIO, and then it doesn't seem to be as quick once we put it into service. Golly, go figure. And then finally, a lot of the solid-state drives that are out there slow down over time, a lot over time. But thankfully, we can monitor this. The slowdown over time is really interesting, too. So if you go into the technical manuals again, I know you're not going to do it, so I'm just going to tell you how this works. So for a lot of drives out there, like the SandForce controllers, they will tell you that you actually have to pull it out of the server periodically. So you have, say, 4 drives in a RAID array. you have to pull one of the drives out, go put it into a Windows machine that doesn't have any kind of RAID, erase it, clean it off, put it back in the array, wait for it to finish recovering, and then pull the next drive. Yeah, none of you are nodding like you knew it, right? Yeah, this is the fun along with solid-state drives, and it works, and it does make a tremendous difference in terms of performance. So there's counters that we're going to have to measure to make sure that we're actually getting the stuff that we paid for. First off, average seconds per write and seconds per read. This is how fast your storage is responding. There are other counters that go for the amount of load. This is strictly how quick your storage responds to the load. For TempDB writes, which is often what I see people using these solid-state drives for, if it goes higher than 20 milliseconds for writes, you have a problem and you're not getting what you paid for out of it. They should usually, when you put these things in, they're closer to 1 or 2 milliseconds, and then over time they just drift right, start back up. Once they're in the 20 millisecond range, you're right back where you would have been with magnetic drives. You need to start doing the pull and shuffle or look at how much memory you've actually allocated to these drives. Any questions about this one? Yes, go ahead, Matt.
So is trim not supported in an array then?
Exactly. So trim is not supported by RAID controllers. RAID controllers sit in between the OS and the drives. When the RAID controller hears the trim command, he just goes, yeah, whatever. Give me the next command, and does not pass it down to the drives. Yes?
So a slow SSD is truly comparable to a magnetic drive?
I had one particular client who went and bought a whole bunch of very expensive solid-state drives. And this is not the problem with the manufacturer. This is the way that the company decided to deploy them, with not enough memory involved dedicated to the drives. Their average writes were 2 seconds. Not milliseconds, but 2 full seconds. To the point where we did a quick stream of tests, they would have been better off putting TempDB on the C drive of the server than they were on the solid-state drives. And for a short-term fix, that's exactly what we did. Put it on the C drives, pulled the solid-state drives out, reconfigured things, dumped them back in, and off we went to the races. Which, if any of you are consultants in here, that's how you can look amazing without having to have them spend any money, and all of a sudden everything's faster. You don't have to tell them you heard it from me either. All right. Any other questions on solid state? Yes?
Are they more appropriate for files that are mostly read that aren't being overwritten all the time?
That's a great question. So it depends on your workload. Kendra Little, one of my partners at Brent Ozar Unlimited, on SQL Cruise, how many people did we have out of SQL Cruise? Was it just Dev in the back? Oh, and Mike, yeah, his tube has been. And Yanni in the front. I keep forgetting you're up front here. Yeah, you're all quiet down. Well, because you're working on your phone. Start paying attention. Making notes, yeah, right. Yeah, whatever. Where even was I? Oh, so she on SQL Cruise, she demonstrated that sometimes they're better off for data files than they are for log files. If, for example, we're not able to keep all of our data in memory and we're able to satisfy like blocking transactions by getting them off disk fairly quickly. Most of the time, though, I see them best off for log files. If you have a lot of databases on one server, magnetic drives suck at random writes, whereas solid-state drives are actually pretty good with that. More questions? All right. Oh, yes.
Is there you mentioned this procedure for pulling out the solid-state drives and putting it back in. How do I find such a document? If I do FusionIO?
So that one, FusionIO doesn't have the trim problem, although they do have other installation problems that you have to be aware of. I like FusionIO, but it's hard to find their documentation sometimes. So here's what you look for if you have FusionIO. Look for the documentation for the HP.io accelerator, and also look for the term SQL Server with it. All they're doing is they're taking FusionIO stuff. You're recording this, and I'm going to get in trouble for this. They're adding on a price. I'm sure it's completely fair and legitimate, given their business, whatever. And then they're rebadging it and putting together documentation for it or whatever, specific for their blades and their DL 380s and all that good stuff. If you search for that, I think their documentation is easier to read than FusionIO's. I'm going to hell. I know I'm going to hell. This is why vendors never call me for coffee. So that's one, except Redgate. Redgate's adorable. Anantech.com has fantastic documentation about solid-state drives, and they explain in detail the problems with wear leveling and trim. So guides talking wear, leveling, and trim. So that is a separate set of topics. Every time that Anantech does SSD reviews, they talk about the problems inherent with the drive, whether it has issues with write leveling or trim. You're not taking a picture of me, are you? I'm not that attractive. Yeah, that's what I've done. Nobody wants a picture of me. All right, so.
That's okay, Brent. We still love you, but you're not worth it.
Love is a strong word. Yeah. I have a face for radio, right? Yes. Yes.
How does the SSD thing handle in the SAN? Is the SAN the same as the memory? I mean, do you treat it the same way? Or?
It depends on the SAN. So some SANs are smart enough that they understand how this stuff works, and they do their own internal write leveling and trimming. The lower you paid for your SAN, if it's not, yeah. So what I see people is doing, buying a $10,000 SAN and throwing solid state drives in there, expecting them to go fast. If it wasn't built for solid states, I would do the pull and trim thing.
And how would you monitor? Do you still do the same thing as monitoring the physical read and write on those, because SANs are maybe a little different?
Yeah, so of course we don't get to see individual reads and writes inside the SAN, so it's hard for us to tell. What I would do is I would still continue to monitor it at the server level. And of course, one way you could do it, I would be a bad guy if I didn't say, Redgate has this already built in for SQL Monitor. It's a call right now from Redgate. Would you like to buy the product? So Redgate already has stuff like this built in and has nice little spark lines. I'm a big fan of Edward Tufte for the little spark lines for things like response time. And it'll tell you how response time is on every single database. I can look at it. Unfortunately, I have to scroll down a little. This is why I give the whole complete slide deck for examples. If I scroll down and hit disks, I get average read and write response times, and I can pick the time duration. I can say over the last month, in which case we'll see our little solid state drives going bloop, 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 and it happens universally. It's not any one vendor. They all suck like this. Any questions on those?
Well, so if you had
Yes.
a SAN, if you had a LUN that was all on SSD, right?
Yes.
SSD in the SAN,
Yes.
those counters would still be relevant.
Absolutely. And I think even if they're only using a small part of it for like caching, you're still going to see the stuff go blah, blah, blah. Because the other problem that we have is the SAN administrators will initially buy solid state and they won't buy enough of it for caching. And then over time, as people add more LUNs and add more data, our response time starts to suck.
So as you have to trim because your response time slows down, is there a point where you just don't get the performance back after so many cycles for trimming?
That's a good question. So there are some manufacturers, because remember, solid state drives have a limited lifetime in terms of writes. The more writes that you do, the drive gets burned out. Man, you would be surprised. So I've had a lot of clients. Oh. It goes back to the hot and crazy thing. Like sometimes we have really bad luck. And of course, it gets even worse because what do? We buy all of the solid state drives at exactly the same time. We put them in a RAID array that is all getting written to at the exact same time. And when we have failures, they just go. I had one client who the whole IT team was on the way out to lunch about 11:30. On the way out the door, they got one email saying, oh, HP System Insight Manager says we had one drive just fail. We'll replace it when we get back to lunch. The hot spare will take over. Before they could get back from lunch, another drive had failed and bombed the entire RAID array because they're just not as reliable as I would like them to be. Now, does performance eventually go over time over trimming? I haven't seen that. It's been, as long as we take care of it with trimming and leaving enough memory, I've been able to get consistent performance throughout. So some do. FusionIO, for example, claims that their drives fail into read-only. If you go through my blog, when I first initially tested the first round of models that came out, I could get them to drop offline completely. I mean, they would just disappear. So I would treat them exactly the same way I treat a hard drive. It's not the only biblical copy of the truth. It's going to die sooner or later, and you're lucky if it fails read-only. More questions about solid state? How many people are using solid state in their SQL servers? Well, that's a few, yeah. All right, I'm going to blow past a few of these. Oh, yeah.
One other question for you. So when you say lots of memory on FusionIO, like you're talking like 10%, 20%, or
50, 60, 70, 80 gigs of memory. And it has nothing to do with the percent of the host OS. It is a hard-coded amount that's based on the size of the drive and the sector size on that drive. The more sectors that you have, the more memory it needs.
so like for 1 terabyte of data, you need like 50 gigs of FusionIO.
Or more, yeah. Yeah.
That's an impressive partnership with the memory.
Yeah, yeah. horrific. And of course, plus two, what do? You buy pairs of them to put them in mirrored pairs. You don't just buy one. So then you have to calculate that across all of them. And as long as you're playing around with those, you need to be aware of how much power they draw as well. Kendra's been doing testing with some of the other vendors, and we've been able to have the power supplies on the servers brown out. You know, the server will go offline because we're trying to write everything simultaneously striped across all the drives. So, yeah, we have lots of fun. The older I get, it's just the uglier my surprises get. You know, the words. Nobody ever calls me for, hey, man, we left auto shrink on. You know, no, nobody seems to call me for that. Yeah. You guys read those blog posts, you learn that, and then you call me for the hard stuff. So the next scary surprise that I'm going to talk about is TempDB dragging a leg, you know, like those nasty monster movies, where you need to talk a little bit about internals first. Whenever SQL Server stores anything on disk or in memory, it does it in 8K pages. And I'm illustrating this in one little spreadsheet cell here. Usually, we store them in groups of 8 8K pages at 64K a pop. This is called one extent. Now, back in the old days with SQL Server, disk space was very expensive. And when you wanted to create a new table, SQL Server didn't give you a whole extent. It gave you 1 page at a time until you'd used up 8 pages. And then SQL Server goes, oh, I understand you're important about this. You're actually going to load a lot of data. From here on out, I will give you whole extents at a time. You get 64K at a shot. So our data files look like these big old messes of groups of 8K pages. Usually, it's all 1 per object, but not for times when we're creating a lot of tables. If we're creating and dropping a lot of little bitty tables, we're going to end up with these things called mixed extents in the database. So I've got a few of these here that can be shared between several different tables. If I go and create a new table, SQL Server scans across here and says, I have a little space here in this extent, this mixed extent, which is shared between a lot of objects. I have this one available. I can land your temp table right here for the first couple of pages, and then for over here for the next couple of pages based on how much is going on at the time. Whoops, went too far there. There is only 1 page per 4 gigs that tracks where these mixed extents are at. Only 1 page. So every time I need to create or drop a temp table, I'm getting, or expand it by a few pages, I am getting involved with this one little guy right here. This is why people tell you to add additional TempDB files. It is not because there's some kind of magical load balancing going on. We just need more of these. So if I have 4 files for my TempDB, now I have 4 of these SGAM pages, shared global allocation map pages, to help balance out the load of where do I go create these initial pages for objects. But not if I do this. If I don't keep the files all the same size, if I have 1 file up here that's small and 1 file down here that's big, this guy is going to get a whole lot more action than this guy. I'm not making jokes there. Not the big guys get more action, believe you me. This is why why am I being taped for this? Man, I'm going to regret this for the rest of my life. Redgate's going to put together a highlight reel of everything I said bad here and in Chicago. This is why we can't bring him back. So there are a lot of ways that TempDB can go horribly wrong. Only 1 TempDB data file, because then at that point we only have 1 SGAM page for the first 4 gigs that's going to be under heavy contention. Too many TempDB files can also cause you a problem. Out of balance TempDB files where they're not all the same size and not all growing the same way. There's a lot of things that can cause us these problems, but the cool thing, again, is that SQL Monitor has a lot of these checks built in, and there's more if you search for TempDB over on the custom metrics site. TempDB allocation contention, this check will tell you if you're running into problems with that SGAM page, and you need to add more files to the more TempDB files to that database. More TempDB files. There's only one database with TempDB files. Otherwise, it's extremely difficult to catch this, and you're just going around the blog trying to find out how many files should you add. And if you go to the extreme of adding 1 per core, that actually makes performance problems worse unless you're undergoing TempDB allocation contention. How you start and configure new servers from scratch, start out with just 4 data files, but the important thing is that they should all be equally sized, and they should all auto-grow in the same amounts. There's some trace flags we can play around with for that. We have to keep watching this because every time SQL Server brings a new feature out lately, they've all been using TempDB. Always on, the new always on availability group stuff, stores statistics and versions in TempDB. So just when we think that we've got our TempDB sized appropriately, all of a sudden we need more throughput on it. So it's something that we can never stop monitoring. Any questions about TempDB before I go on? Yes, in the back. It's a great question. So 1118, trace flag 1118 is related to TempDB use. Most of us are recommending that you go ahead and turn that on by default now and roll with it. I hate doing that on slides because I really like to think of SQL Server as like a modern airplane. Modern airplanes are so advanced they practically fly themselves. There's only 2 things in the cockpit. There's the pilot and there's a dog. It's the pilot's job to feed the dog. It's the dog's job to bite the pilot if he touches anything. Unfortunately, SQL Server doesn't have a dog, and we go in there and we play around with all kinds of things, not understanding the ramifications. If you don't need something, don't touch it. 1118 is one of those where I think most people need it, but I'm hesitant to recommend it by default because what's going to happen is 3 years from now, Microsoft's going to put out an improvement to SQL Server, RT or whatever they decide to call it next. We won't need it, but I'll be on tape forever saying everyone should have it. So if you're watching this in 2012, 2013, or 2014, you should probably have trace flag 1118 turned on. But it's time limited. And don't touch it and keep out for the, I'm the dog is what it ends up being. I'm the one who ends up having to bite people when they touch things. Second to last one, your tables are larger than they appear. Going back to our little spreadsheet demo illustrations here, let's say that I've got an 8K page. I've zoomed into that cell. And this is all just one 8K page, and it's my employees table for Brent Ozar Unlimited. Of course, I was number 1 because it's named after me. That's how that kind of thing works. So I've got my record in there. I'm ID number 1, Brent Ozar, my home address where you send me flowers and cookies, my phone number, and all that good stuff. Well, as we grow, we add in more people into this table. And the more that we add, the more full this page becomes. So we'll add in, my last hire was Bill Gates. He was kind of bored, and so I took him on. If I need to update something here at this point, if all of a sudden, say Kendra changes her address or Jess, goes from 321 half marathon way to 321 marathon way, when I change something in here, there's no space left. If I do an update on this page, I'm kind of screwed. So what SQL Server has to do is tear that page in half and put some of the people on one page and some of the people on the other page. And I'm up there going, Bill Gates, I'll always love you. But we're further apart now. This is very expensive for SQL Server to perform. Page splits are very I/O intensive for SQL Server to do this. There's a lot of reasons behind that, but in order to fix that, what a lot of people do is change fill factor. Fill factor is the number that controls how packed in your pages get upon index rebuilds. So if you set it at a much lower, I've got the wrong, let me go on one more there. Is that good? Yeah. So the default level for this is 100%. SQL Server will pack all of your data in as close as it can possibly get. But if you do a lot of updates in place, or if you have the kind of design pattern where a lot of fields start out null and then you update them, like you start out with order process date is null or ship date is null, and you're constantly going back and updating those fields, they're blowing out continuously wider and wider, and you're continuously doing page splits. You could fix that by turning fill factor down, and you can turn it down at the server level. Don't ever turn it down at the server level because you don't know what other databases are going on in there. Or you can do it at the index level. Because if you think about it, remember my clustered index that I had back earlier, it started at 1 and continuously went up higher. But I bet on that table, I've got an index by last name. And I'm constantly inserting people all over inside that index because I don't hire in alphabetical order. It's a good thing my friend John Zegdo would be doomed at that point. So that's why it's important for me to change it on an index-by-index basis. I may not need to change it at all on the clustered index if there's an identity field that always goes up. I may need to change it very quickly on the last name index, which is constantly splitting around. So that's exactly what I would do as a database administrator. This is a picture of me back from 2004 when I thought I was the bomb. And although if you looked at the books on my shelf, none of them had anything to do with SQL Server. I didn't need it because I was on the internet. And I could find all kinds of bad advice out there, and that's exactly what I would do, is I would set fill factor way lower. There is actually a banking application out there today that tells you your fill factor should be 10%. 10%. It's in their best practices, guidelines, documentation, the whole 9 yards. Oh, that fixes page splits all right. Oh, yes, it does. You have very different problems at that point. Your database is twice as big, 10 times as big, and you have no way of seeing this. Again, it doesn't surface anywhere in SQL Server Management Studio. All of these things take longer. You have the same amount of data. It still takes longer to do backups and DBCCs when your data is spread across more pages. You can cache less in memory. Your database falls out of memory faster because SQL still caches those 8K units. It doesn't cache just what you use. It caches those whole 8K pages. So doing this, what I want to do is I want to go find this. I want to say, again, my buddy sysindexes, show me where fill factor is not 0 or 100. Both of those numbers are the same. SQL Server knows that if you set it to 0, you don't actually want 0 data on your pages. You thought you meant 0 free space. So both of those are the same, and you can see when you look at that, fill factor is whatever. I stumble across this all the time because it wasn't you, it was the last guy who was playing around with how this worked, and we never thought to go look for it. First off, leave the server level fill factor at 100% and only play around with this again when the dog isn't going to bite you, when we're not going to really get into trouble with our page splits. Last thing that we're going to talk about here today is the call is coming from inside the house. I bet a lot of us in here work in environments where there's multiple database administrators, multiple developers, and I know you guys have great relationships with them, and they would never hurt you, and they would always tell you exactly what they're doing, and they would document their changes and leave them behind for you and tell you in advance to make sure that you were all on the same page. This is just about for the rest of those people at your user group that you can go back and tell about. So I was constantly working with people who were not like that, who would go back behind me and change all kinds of stuff. So I wrote this whole SP Blitz stored proc, and it finds all kinds of things about your server. But if your job's anything like mine, I didn't really have the time to fix this. I kind of had to leave it exactly the way it was. And every week or two, I could make some small improvements, fix some of the wacko fill factor problems or security problems. And sometimes I just knew I didn't have a choice. I had to leave them the way that they were. So I've added something to SP Blitz. I've added a parameter called output type. By default, it dumps out this big old table that tells you everything that's wrong. Your database isn't wrong. It just has beauty marks. We'll say it that way. This just gives you the number of beauty marks that your database has. And so you can now alert on this if you're using things like Redgate SQL Monitor to tell you exactly how many warnings you have so that when it changes, you can go look. Instead of going, oh, something just happened, you're going to find out immediately instead of waiting 2-3 days when you run across the problem. Because this whole thing runs in less than 5 seconds on some unbelievably ginormous databases. So you just want to set up a metric in Redgate SQL Monitor to see when that number changes and trend it over time. Or, because we're getting near the end of the year, I like to have ammo for raises. And I like to be able to have a little graph that shows how much I've fixed. In a perfect world, I'm going to start adding this to my monitoring software and see the count of problems go down because you know our boss never has any idea what we do. They think that as long as the server's not on fire, we're too busy surfing Reddit, and we're overpaid already as it is, which is why you guys are free training, right? Because you don't yeah, I know how that works. My other favorite trainings are like last week I was in Las Vegas, and I have the other problem there. Everybody there has already spent all kinds of money on their hardware. They're Vegas people, right? Oh, let's go buy big terabyte servers. Oh, our database still sucks. Yeah, it's because you don't know how to use an index. Not you guys. You guys have already used it. You know the index thing because you're here for free training. So the 6 things that we talked about today. First off, people who are changing and disabling indexes without you knowing, or ETL processes that are disabling your indexes. You won't have any idea just looking in SSMS. Available memory that isn't actually available, wah, wah. And when you go back to work, this isn't just a SQL problem. This is everything. IIS, SharePoint, Exchange, all servers that you have. You can suddenly look like a rock star when somebody's having performance problems. You remote desktop in, look at Task Manager, say, oh, you have no free memory. Let me show you a blog post by the Exchange team that'll tell you why this is all broke. And that's how you become a Microsoft Certified Master. You fake it. Yes. Not really. There's tests. Storage that's and they suck. Storage that slowly slows down over time, especially the solid state stuff. It's interesting that magnetic never had this problem, and now it's a new problem that we have with solid state drives. TempDB with a limp because one file is too big and we're having to drag it along, and it's the only one getting all of the activity. A fill factor that's killing your database by making it larger, not fitting in memory anymore, and your backups are taking too long. And then finally, people who are just working against you and not telling you. So all of these are solved in a few simple ways. First off, get my Blitz script. It's completely free. And you can assess all kinds of ugly problems in your environment. That's at brentozar.com/blitz. This week at PASS, I'm also adding performance checking into it as well. That'll catch things like implicit conversion that's sitting around in your plan cache. Leave the server's defaults alone, except for the things that I recommend on my setup checklist. And in each of those things where I tell you what you should change, I give you extensive documentation from Microsoft to say, here's why you need to change this particular thing. When you change something, measure the effects. So often I see people set up a trace flag, change a configuration parameter, thinking it's going to make things better, but if you don't prove it scientifically, which is one of Mike actually got me started on that. Mike was originally a science student, and he's like, well, you have to have a hypothesis, and then you prove it, and it becomes theory. Did I get those orders right? Hypothesis, yeah, see, woohoo! Normally I just take all the credit, but he's in the room, so I have to give him the credit. So. Use a monitoring tool like Redgate SQL Monitor. I don't care what you use, but please, for the love of God, don't just come into me and say, the server's slow. What was it like last month? Better. Yeah, okay. How fast do you want it to be? Enough. And then finally, get custom metrics. Redgate, a lot of us from the community put in work to give a lot of extra custom metrics for the things we're passionate about. Me, it's like disabled indexes. You can download those for free at sqlmonitormetrics.redgate.com. Any questions from anything we covered today? You're all ready to get the hell out of this hot room, right? Woo! Well, thank you very much for coming in to see me, and hope the rest of your rooms are cool. Thank you, guys. I'm really glad I got 2 things of tea, that's for sure.